Thank you. Good afternoon and welcome back to our afternoon session. We'll begin with our highly anticipated panel, and the topic is Open Source is Transforming AI and Hardware. Our scheduled moderator, Dylan Patel, had a last-minute conflict, so filling in is the man right here. Doug O'Loughlin, an analyst and founder of Fabricated Knowledge, a research service focused on semiconductors. So, ladies and gentlemen, please welcome our panel and Doug O'Loughlin right here.
Hello, hello. Okay, so we're going to have some introductions here. How about we start with Raja first? He's been making GPUs for a long time. Now in a stealth company slash, well, I mean, not that stealthy, but formerly AMD and Intel, AMD. I don't think Jim needs a lot of introduction. Everyone knows who Jim Keller is. You know, legendary hardware designer. We have Chris Walker, who is working at Untether AI. He was at Intel for 30 years. And of course, we have Charlie Chang, who's a board advisor for Andes. So without further ado, we're going to talk about AI and open source. So just kind of open question for the panel. Sorry, give me a second. One of the things that I think is really interesting about the ISA work is that there's the custom extensions that often happen with RISC-V in particular, right? One of the reasons why x86 is so well adopted is there's one spec. So how do you think you can get the RISC-V ecosystem to be more open, right? Instead of everyone having their own custom ecosystem or custom extensions, you can have an open ecosystem based on the compilers and a single standard spec.
You want me to go first?
Yeah.
First, I have to ask Charlie, have you worked at Intel?
No.
I was going to say...
You're excluded from the reunion.
Yeah.
It's just the three of us refugees here on the end. I was just checking.
No.
So, yeah, well, there's creative tension, right? Because you want to be able to change stuff so you can do what you want. And then you want a big solid code base so things are mostly compatible. Now, the cool thing about modern compilers is they can ask the processor what do they have. And RISC-V has pretty good definitions, maybe too many definitions, but there's a whole bunch of flags that say what features are supported, and then you can compile for that. And that information actually goes in the binary. And then when you're running something, the CPU looks at that and can tell what's going on, and it actually works pretty good. Now, that said, about a year ago, we did an experiment where we brought up some server software stack on a virtualization layer, and we downloaded a boatload of binaries and ran it on QEMU, and we just wanted to try it out. And one of the biggest things was, did all the tool chains properly propagate what the enable bits were for the different features? And the answer was mostly they did. And most of the things we found had already been fixed, but not properly upstreamed. So it's pretty well known technology. And so I think mostly that's going to be fine. If they have a new big drop every single year enabling more stuff, that will be less good. On the flip side, like we pick RISC-V because we can change it. And being able to change it's really important because we needed to change it and we couldn't build the product we wanted without changing it. So it's a real thing.
Yeah, maybe even from the good old days of x86 experience-wise is everybody had different extensions. There's different, and I read both, and there's different approaches, and you have to make it, is it compelling enough for people to do the work to optimize around it, right? There's a baseline of flexibility, functionality that you can get, but if you're going to go your own way and be creative, you got to create enough value for it, and you know, without spending a ton in developer work to pull it across the line.
I'm the host. I got to go last.
Yeah. So my take on extensions is a little bit different on, especially in RISC-V and open source, right? As long as you're the one dealing with those extensions, in the sense that I'm providing you a solution, okay? Yeah, the compiler stack and the libraries, whatever required for you to go do your stuff. It doesn't really, you actually keep adding all extensions away, right? So extensions that I want you, the whole ecosystem, to support, or like, it go up the stack to the all the way to the data scientist level, that's a whole different discussion. And what I found in this last year of the stuff, none of these people up at the stack, they don't even want to know what an extension is. Actually, it's us at the hardware level and all, we talk and we stress about it. They don't even want to know, like, how you solve the problem. They have their APIs and the infrastructures they're working at the high level, and you make it work. So my take is, I think we stress way too much on standardization. And if you look at open source software, it is anything but standardized, right? That's the both beauty of it and the pain of it. So people who package it can make money, right? But it is not like you pick any open source project and you just say, oh, I hit compile and just run and it works on anything. Nope, that's not true, right? It is, you have to go kind of, test it, package it, and do some, massaging of it to get it running on the stuff. And you're free to make that changes, right? You are free to ship that without waiting for somebody to, provide you a driver or something. That's the power of open source, but also the cost or the burden of open source.
Yeah, so as Andy's licensed his own, the RISC-V cores to customers, I'll speak a little bit of how customers sees it. There are roughly 3 kinds of RISC-V customization or extension to the instruction set. One is clearly not viable, which is something that changes the very high layer at application level, where industry standardization is needed. So very few of our customers, I can't even think of one, that think about adding instruction sets there. And then there's the compute side of, and at the low level side of it, there are a lot of opportunities, especially in AI, to add instructions to accelerate. And in AI, acceleration is the name of the game. And for those customers, the question is not whether there's going to be a problem, because the expectation is actually how can a RISC-V CPU vendor provide all the ecosystem support so that the customization happens quickly and smoothly. And that's where Andy spends a lot of time. The one in the middle is where the contention is, where it's not per se all that difficult, but it is part of the standardization thing, like a new data representation, 8-bit floating point or pack representation of floating point. That stuff, affects compiler, and if you can't get good compiler support and you can't upstream that, it's a big problem. Even bflow 16 is not well supported in RISC-V today yet as a ratified standard. So I think the way I think about it, there are 3 different parts of it. Once customers decide to add instructions, the upstream open source support kind of come automatically, and not automatically. It comes, and customers are pretty savvy. They can just go to upstream and download everything that's customized and compile it. So we've had cloud customers, some of the largest clouds that use our processors, they're pretty used to, getting the stuff from upstream with customization. So.
Perfect. Great questions, or great answers, guys. Raja, I'm going to actually have a question for you, because we were having a conversation about this before. Open versus generalizable, right? Kind of talking about that kind of difference between, and my understanding is some of the work that you're doing is to make sure to clean up all the open source aspects. I'd love to ask, frankly, do you expound on that, our conversation we had before, and then we'll take it from there.
Yeah, the conversation we were having during the break was a lot of times we misunderstand, or like open means very general, right? That generality and open aren't always the same, right? You could achieve the generality because it's open. You can go modify it to right, kind of make it work on your platform or with your software or with your hardware, right? So you have the fungibility, you have control, but by default, an open source thing may not be general. I mean, we have a living example of PyTorch. Okay, PyTorch is open, right? And the first line you see on a model you download from Hugging Face, it has, tensor a dot device CUDA. Okay, it's not general. It only works on NVIDIA, right? And it's all open source. So you say, oh, it's all open models, open source and all. It's just kind of infested with CUDA. And then now, the cool thing is you can go modify it, you can put an import library, you can change it, you can kind of ship your stuff. But open source is infested with, I call proprietary stuff, right? It's funny because we say open and proprietary as if they are two separate things. But there is this whole class of open source that is infested with proprietary elements, right?
Do you think RISC-V can change that? That's kind of the follow-up question, and then also for all you guys to answer as well.
Yeah, it can, and in a very weirdly indirect way, right? Is that, we're talking about all these compilers and dealing with data formats, all of this stuff, right? The power of CPU core, and I always, for a GPU guy, right, I probably talk about the importance of CPU core than all of the CPU people in the world, is a fungible CPU core that is accessible to us can solve much of this, nastiness in the proprietary stuff. But you got to architect your system to leverage RISC-V core and the generality of it to deal with. Essentially, you need a core or a set of cores dedicated with dealing with the messiness of proprietary software stacks, right? And they're small and cheap. Right? I mean, in the grand scheme of things, these are like 1,600 square millimeter dice that people are building for AI. And, 4 good high-performance RISC-V cores are like less than 10 millimeters square, right? That can solve a lot of kind of, your problems. So that's a beautiful thing. And you don't have to go line up behind Intel or somebody else to get that generality. You can just roll up a solution yourself.
I mean, in some respects, it'll be the customers who want the flexibility. They want to be able to leverage across different solutions that will drive it. They're going to say, for design in, unless they want to be, very vertically orientated, will perpetuate the need for RISC-V to solve it, right? And so we'll all come at it in a slightly different way, but the answer is going to have to converge because at the end of the day, the point of an open ecosystem, the point of why the end applications and markets want an alternative and a solution is for flexibility, right? And so I think it will be an application and user and market driven, and it'll pull us there.
Yeah, we had a funny experience because we built a bunch of test infrastructure for the famous models that say, include NVIDIA. We found out, first of all, just commenting that out mostly worked. So it says include NVIDIA, but you actually don't have to. Yeah. And then some models that when you run them on NVIDIA, you have to comment that thing out that says NVIDIA. Otherwise, it doesn't run on NVIDIA because the NVIDIA libraries also are changing a lot. And when they posted the include NVIDIA, it may or may not have worked with the libraries you have installed on your machine, but when you comment it out, you kind of bump up to a dumber driver. And so there's, that's a mess. I think at some point we're going to say, ChatGPT, get the model, look at it, fix it, and then run it. And I'm kind of serious that, like the day of fragile binaries and things, I think is slowly going to go away. And as long, a good program will publish something about what it's doing and why, and then a good runtime system and environment will look at all that information and then make good choices about what libraries to include or not. And you also have to tell the system, especially in AI, do you really care about super optimized performance? Or do you just need these 10 components to work? And, and then what's your trade-off on effort? And it seems like that kind of stuff is going to naturally evolve. And But to Roger's point, like putting RISC-V like processors at every level of compute, because if you have to go way back up into the data center to go figure out how to modify it, like it'd be better if better programs actually got to the hardware where they could be locally fixed as appropriate to the software and hardware stack you have. And I think that's all basically doable. I'm quite interested in making that happen.
By the way, ChatGPT's already got smarter. It's funny story. Like 4 months ago, when I asked ChatGPT to write a PyTorch program to add 2 tensors, right? It said C equals A plus B, and then I said, oh, make it hardware accelerated, and it said, A tensor dot CUDA GPU, B tensor dot CUDA GPU, and if you do that again, actually, I'd ask people to try doing that. The latest version, what it does is it adds a check. If your device is NVIDIA, then add CUDA device. If not, default to CPU. So it's already like, it's at least CPU compatible, not other stuff, right, in the thing. So it is getting there to, Jim's point.
Yeah, nothing yet.
Okay, so I actually want to ask you about that. It sounds pretty interesting.
I have a question, actually.
Yeah, go for it.
You to the panel. It's like we say, about back to the standard stuff, right? So Linux is, when we started the RISC-V movement, right, lots of people used to compare the analogies. This is the Linux for hardware, right? Okay. Now, as far as I know, there is no standard Linux. If there is a standard Linux, let me know. I would want to go install it, okay? There are like, so many different. So why do you think there'll be a standard RISC-V? Just a question. It's like, that, Linux isn't a standard. Why do you think RISC-V or like, I'm including all the all the utilities of it, that there should be a standard?
Yeah, and my answer to this is a place where like 95% standard is mostly good enough. Like it's kind of amazing. And then the ability to fix it and change it. Yeah. I still remember years ago, we had a printer on an NT machine and we reported the bug, and like 6 months later we got a release and it wasn't fixed. And 6 months later, we bought a Linux machine which also had a bug in the printer driver, and we called our friends and we fixed it the next day. And what happened is, over a period of a couple of years, all the CAD environments migrated to Linux. And then the CAD guys would complain. It's like, well, we really want you to buy Sun. And for a while, that was a good choice. But then Sun started getting really expensive. And so it was like, no, we're running these other Linux distros on PCs. And then they would say, it's up to you. But the truth was, most of the problems were easy. And then the CAD guys and the Linux people would chat, and they would go, well, let's just cross-test this a little better and clean stuff up. But then consistently, the ability to fix it fast, like waiting for Microsoft to fix a bug was terrible. And you're willing to deal with a little day-to-day carnage that you have a day to a week to fix, as opposed to less carnage, but you never know. If you actually run into a real problem, you're dead, and being dead sucks. So I think that.
Yeah, so I'll tie it back to actually the previous question. I think I agree with Jim 100%. But I think the reason is that open source enabled the needs for RISC-V, and not sort of uniform, fixed, x86 kind of one standard ratified kind of RISC-V, but 95% the same, with customers being able to make their changes. So there used to be a model called ChatGPT, but now there's Llama 3. There is, whatever it's called now, from X. So there are a lot of open models, and I think open models create needs for each of the models, and it opens up opportunities for custom silicons that will no longer run, CUDA and on top of NVIDIA hardware. It will run from whatever hardware that supports these open models. And everyone's notions about how to accelerate these models will be different because models are different. X probably produces incomprehensible, grammatically incorrect English, but it will be a very powerful model for the modern day language use. And it probably will require a very different hardware that is 95% RISC-V standard, with the last 5% being up to the silicon creator's ingenuity. So I actually think of it as RISC-V meeting the need as opposed to RISC-V solving a problem that enables open source.
I think maybe the other part of openness, and to use the Linux example, it took time to get to a certain point. And what the openness does is, back to your point, where's the innovation or where's the ingenuity? It enables a pace and speed of iteration across hardware, where people are going to move between companies. People are going to, we're all going to iterate towards a space. And I think openness from RISC-V allows multiple companies to get there.
Yeah, and I think the innovation is happening. I was talking to one of the attendees here, and I recall that when Andes first went into machine learning, our first product, 27V, lasted 3.5, 4 years. Second product, 2 years, 45V, and we have 3 products coming out all within next year, 46, 7, and 8. And I think that's we are moving faster because our customers are demanding more at a rate that is a little scary. And so I'm hoping we can keep up.
Yeah, I think there's a good analogy with Linux, right? There is the Linux kernel, right, which is common, the stable point, and then the variations in user mode, in desktops, in this, that, all that stuff, right? So there's a core RISC-V instruction. The 95% is kind of, morally equivalent to the Linux kernel, right? Don't mess with it, and don't stress on the variants, because I see the people that, hey, you want to do your own user interface on it or a desktop on it for a particular embedded use case. Go ahead, do it, right? And you're solving a problem for the customer, right? So I think where we draw the standardization boundary and not, so all acceleration functions, for example, right? We're still discovering. We're still researching, experimenting. So yeah, let that be, kind of free for innovation than premature standardization.
Perfect, guys. Actually, I want to ask a kind of a similar question. We're talking about all these things and how we're going to get there, right? But right now, still today, I would argue 99% of the installed base is by one company that's relatively proprietary, and these are all benefits of being open. But this company, like Chris was talking about earlier, it's about a solution, right? And Roger was talking about this earlier. It's a solution that the customer takes and wants. How do we get from this relatively closed system where they have the software, hardware all together to being able to iterate, showing all the benefits of the open side? Because it seems like it's a gap between there and here, right? How do we, what solution gets us there? Whether if it's a flavor of Linux that we adopt, or how do you guys see us getting to that future?
Well, first I'd say it differently. It's we don't need to get anywhere, right? The truth is, RISC-V is actually successful, and people use it all over the place. The software works, the tool chains work. You have demand for extra versions of your product. That's a really good signal. We have demand for our product. We're building product. We're pleasantly surprised how good both GCC and LLVM were. And then it's sort of like the stock market watchers like to say, well, how are you going to compete with NVIDIA? Who cares? I don't want to compete with them. They're doing their thing. That's great. The question is, do we have business? We're building technology. We have ideas about innovation, what we want to do, and then do customers come talk to us? And the answer is yes. Do they want to build their product? Yes. Do they want, do they know what they want? Yes. Do they know what they want to pay? Less, right? So these are happening, right? And then all these decisions add up over time. And Chris and I, we were at there was a financial panel, and I was with Victor Peng, and Victor, he's a really smart guy. He said, our customers don't care about the low-level kernels and drivers. And I was thinking, like all my customers care about those. Like, so there's customers that don't care, they want the solution, they pay extra money. And then there's other people who are like, I want to see how your software works, I want to see how the driver works, I want to be able to change it, I want to be able to license it and modify it. That already exists. So I'm not really into how do I get somewhere. I'm already where I want to be. And I think RISC-V is actually already in a really good place, which is it's a solid technology that you can use to build your own product. And if you want to build your own product, that's great. Now, there's a different thing, which is, will someday RISC-V servers or AI disrupt the incumbents? And an answer to that, like, does anybody read history books? 100% chance of that happening. It's right, because every incumbent does the same thing, is they get to market, they narrow their focus, they try to make more money, and at some point, that turns on them because people don't really want to be a cash cow for
Well, they get captured in their own business model, right?
Exactly.
There's no way out once you have Wall Street expectations at a certain level. You cannot take. It's very difficult to take the risk to get out of that. And you know, one place where maybe standards do help is like interconnects. How do things play together, right? It was, you know, it wasn't really conceivable a few years ago to be able to mix and match like, you know, we're starting to see today, or that like Raja and I did, I don't know, 5-8 years ago, of creating different types of products, you know, some from competing companies in some cases, right? And so I think that's that's how, you know, the incumbent gets disrupted. Is, you know, we're not captive to a single, as a collection, we're not captive to a single business model. It's not about getting there like you're in a planned economy, right? Mm-hmm. The market's going to demand those capabilities. Automakers are doing it now, right? Who'd ever thought that they'd want to, you know, define their own architecture at a silicon level, and then create the pull and the requirements for, you know, Jim's company or my company or our companies working together or whatever, to figure it out, right? And those are the unique things that are happening that I think are the big part of the disruptive opportunity.
So I think to tie what everyone, you know, all the panelists said, and I think technically, what I think I hear is that RISC-V as it is today is getting a lot of adoptions and proliferating and gaining momentum. But the building of the pieces, you know, perhaps not as visible. It starts with a PyTorch, which is an open framework that is not proprietary, and a lot of progress being made. If you just look at LLVM, as Jim alluded to, LLVM is a machine learning AI compiler, has gained a lot of expertise and capabilities overnight, and is now closer and closer to PyTorch than ever. And on top of that, you know, machine learning models are now open source as well. So everything is becoming open source, and underneath, running all the open source stacks doesn't have to be, you know, NVIDIA hardware anymore. It could be, you know, any one of the hardware. It doesn't have to be RISC-V, I guess, but increasingly, most silicons are thinking about having RISC-V. You know, I was talking to attendees is thinking about switching from a proprietary ISA to RISC-V, and I think it's a good thing. And I think Jim said it well. It will happen because all the pieces are now coming together, because nobody wants to pay 80% gross margin to one single vendor. It's a hard reality of economics.
So this, I was going to ask a question about from something Jim said. You know, Dylan had this panel last year. Let's talk about some of the momentum in this last year. Like, could you help? You know, that's like a dumb question, but like, what are some ways you think you like RISC-V is in a great place? In this last year, what do you think are some things that have made you feel like things are getting in a better place? Or with, you know, any anecdote, any level of the stack, anything you guys want to share? Because I would love to hear, you know, year by year, what do you think is surprised you? So.
Well, I'll start. I think last year we were here, we were talking about developer platforms with RISC-V, and now we have in our office a RISC-V based notebook, right? That we're using, which is I didn't think existed last year, right? So you can now go to Amazon and buy it, buy a RISC-V based laptop. And in terms of tools, to build your own RISC-V based infrastructure, there are multiple simulator companies shipping, right? Renodes and variety of other folks that also are at anyone can download and start going. So that's the progress I see. On the flip side, I do see, I think this time last year, the whole ARM NVIDIA transition or the merger was still on the cards. And I think that kind of got rejected after this conference. So there was a bit of momentum loss, I see, at least in the business and financial circles or the hype circles, right, on the stuff on the RISC-V as a data center processor stuff. But I just call that out more in terms of the people who want to ride the hype waves and the financial waves. I think those are the ones that talk more cautiously about RISC-V now than last year. Last year they were all on, oh yeah, this is the next ARM stuff. So you see a little bit of that dying, but the actual real technical progress has been tremendous. That's kind of my observation.
Yeah, that's the really important thing about hype waves is there's always multiple waves. So when it was going up, people said, wow, are you going to take over the data center? No. And then when the hype wave crashed, are you going to go back to ARM? No. Because I think that's the wrong question. The waves come and go, and sometimes they drive amazing market caps. And we've been around long enough to see this stuff come and go. I think the charm of it is, so many things work. We powered on our new AI chip. It worked really good. We have a Sci-5 processor in there. Linux came up really clean. We have little baby processors in our network adapters. We started running code on that. We got some of the driver we downloaded from the internet. It's really wild. There's some cool security extensions that we're playing with right now. So we're going to bring up a whole bunch of stuff. The tool chain for everything, like debug, compiler stuff works really well. We're not fighting with anything on the RISC-V side. That's I can legit say we're not. Our next chip, we have this thing called the baby RISC. We're going to use a Rocket core from Berkeley, which is great. We're going to discuss our mid-range core. We are building our own high-end core. We're going to have 4 different RISC-V processors because they have different functions and feature needs. And there's no fight about it. And then some of the big CAD companies are supporting RISC-V toolchain development, compiler. So it's becoming, working man's, tool chains and stuff. And we don't think, well, how are we going to get to X? We're super pleasantly surprised about how good, Spec FP was right out of the box on RISC-V. Vectorization has a ways to go, but right out of the box it was fine. So there's no fight about it. It's just working.
I think the other piece is those of us using RISC-V, we're all in our nth generation beyond where we were a year ago, right? And so as that matures, as our solutions come to market, as we've solved the compiler things, everybody's seeing what advantages we can deliver over an incumbent. I mean, many multiples of efficiency, of performance, of accuracy, and it's what they care about. What's my solution? Help me improve my OpEx. Help me improve, what I'm actually trying to do in a vision network in a field, in ag tech, things like that. And so, from that standpoint, they see it as, based on all of our commercial work, as real, viable, and at the end of the day, when we ship them with partners, stacks and solutions that change their application, they don't care about they don't have religion, and customers don't have the religion about the architecture. They care about what it does for them. And so I think 1 year later, light years ahead on delivering that.
Yeah, so I already talked about the customer side momentum. I think from Andy's, I could see a line of sight to 3 hyperscalers shipping machine learning solutions with our RISC-V in the the system. So, for a long time, it's been just one hyperscaler. So I think that shows the momentum. In the FSD side of it, in automotive, I also see market momentum there. The one thing I do worry about and think that hasn't gone well in the last year is particularly in microcontroller industrial applications, a lot of evaluations on RISC-V. Ultimately, for a conservative market that has been served very well by ARM, and these customers buy off-the-shelf, development package in a shrink-wrap hardware, that market, I don't think RISC-V has made enough progress in there. So evaluation ended up with customers going back to ARM, which is frustrating. So the standardization of a lot of little things, RVA 23 is not quite done yet, and we're almost halfway through 24, and that part of it is just frustrating. And so I think we can all do better in moving the ratification of standards quickly.
I'm going to actually ask that question kind of in the same way. Where's your frustrations with RISC-V? Like you talked about the embedded side, especially on the MCU, right? Where are places, and I mean, you can probably broaden this outside of AI, but where do you think that things could improve? And like, frankly, this is an open mic and you can talk to your audience here. Like what do you think needs to happen for anyone here to answer?
I suspect the RV23 spec was too big a chunk. It should have been.
I agree 100%.
There's a couple of things that the best way to make progress isn't to turn it into a big ball of mud. It's to break down into more independent layers. And I know there's a little creative tension with that, with the number of architectural enablement bits. But I think that should have been done in smaller chunks.
Yeah, agree.
So that's one thing. We belatedly hired a person who's what I call a macro instruction architect. So we had CPU architects, we had some micro architects, we had some compiler, tool chain, and we were just treating RISC-V as a thing out there. But we had to hire somebody who really cared about how that spec worked and how the pieces worked together. And then we also finally hired some really good kernel people, and they have very strong opinions about how binaries are annotated and how they work together. So we were taking advantage of the RISC-V system a little bit without contributing back as much as we should. But we have hired some people who care about that in the open source. We have released some design collateral, a vector unit, a couple other things. We're pushing out a good instruction test so if you're building your own RISC-V, you can use this tool to verify the standards. We put a lot of energy into it, so it's kind of cool. And I think if people do that, everybody does a little bit of it, it'll make more progress.
I'd say it's a little bit on that last point, just more of the infrastructure for all the standard blocking and tackling you have to do in the back end on bring up test. Will extend into other functional safety type of architectures that that part of being broader would be helpful.
Yeah, I would tell a funny thing. I was talking to a bunch of students, a couple different places, and I was like, hey, we're going to release this vector unit, we're going to do this, and they're like, oh, we don't care about that, we just need more DV collateral. Like, that was kind of fun, because what they viewed, the infrastructure is pretty good. What they want to be able to do is download it, do their experiment, and then verify that it's still compliant. And having to write their own verification test, that was the hard part. And then, heavyweight CPU designers, when they make DV collateral, it's too heavy. And I think, like, my team knows how to build, like, great DV collateral. I don't know that they know how to build it so a student can use it. And it's a funny thing. So it makes you think about, like, who your target is.
That's right.
RISC-V, like, won the architecture war at the university research level. It's scorched earth. It's beautiful. And, you know, I want to do something like that for AI as well.
Hey, Doug, do you want to open it up for Q&A?
Yes, I think we have just enough time for that. Yep.
Right here.
Good panel, panelists and the moderator. Good job. For companies like Andis or ARM, as we took as an example, what is important in terms of staying power, growing power, in terms of more users, more in the ecosystem, different ecosystem partners? Is it financial power? Is it the accelerated growth that someone can do faster than someone else who would do? It is the corporate prowess of how to strategize. And what are the factors based on how you think? You know, we can take example of Andis, but there are similar things that are happening in the industry. Standards.
I think we should let the panelists, the guests, to respond to that. Yeah, I don't want this to turn this into promotion. So.
Oh no, you can shamelessly promote yourself. I mean, the important thing for, like, Andy's provides IP to a lot of people. What I hear is it's good quality IP and they have good support. Like that's pretty cool. Like, that's what you need to do. Like, make your customers happy, they'll come back. You don't make them happy, they're not coming back. So, like, IP business is tough because it's complicated. Like, IP doesn't really quite plug and play. You always have to co-simulate. You always have to work together. There's always questions, you know. So, yeah, the mission needs to be make more customers happy and do it. Like, we sold some of our technology as IP, and you know, we're like, it works great in-house, and we give it to somebody, and it all falls apart. Why? Because you built some crutches you didn't know about. You have some understanding that you didn't share. Your documentation's missing whole chapters, and you know, and so being an IP vendor is actually really useful to make the quality of your product better, but it's not easy. And anyway, I hear good things about you guys, so.
Thanks.
One back here. Right here.
Hi, so I agree with everything the panel has said about like the 95-5 split in the RISC-V, you know, that's the advantage of RISC-V, right? You get a lot that's standard, but you have this opportunity for innovation. But in order to maintain that ratio, like the standards have to move with the pace of innovation, like around things like numerics, which, you know, we know that BF16 is one of them, the big gaps. What would you change about the standardization process to help it move along more quickly?
Yeah, the only thing I could offer is make sure you don't take too big a chunk. Like, and yeah.
I think user community pressure and motivations and inputs are hugely important. And I think right now that is glaringly missing. You know, companies like you know, TI, analog devices, you know, everybody needs to jump in and exert influence, because too much of the standardization body in the hands of processor developers like us is not great. You know, I'm a very objective person, but I don't think anybody would agree with that. So, and that's how everyone is viewed, and we end up with these petty bickering in the standards body. I think that's not good. So user input is very, very important.
Was there
It's also a viewpoint of, you know, which markets, right? Because you approach it differently as a, you know, pure play accelerator than if you're trying to build a CPU, and to make sure you don't get captive to just your biggest voice, right?
Right, and having diverse opinions coming in, but quickly converge, especially if it's users' input, it's really good.
Is anyone in the audience that participate in the standard bodies?
It looks like two.
That says a lot, really. You know, we need all of you to have inputs into the standards body.
forward-looking programs, 10-year program they have.
I think we have time for one more.
Okay. How about a big hand for our panel today? Thank you so much.